एसी ऑन है क्या?
पंखे भी नहीं हो रहे।
गार्ड साहब एसी ऑन नहीं हो रहा? हाँ
साइन इन कर दिया?
नहीं, साइन इन तो कर दिया। हाँ चलो वी स्टार्ट। ऑलरेडी बहुत लेट हो गया है यार। बोल दीजिएगा इनको, है ना बस। हाँ हेलो, चलो वी स्टार्ट। Here, what was the last name language modeling? All right, so we start. So this is what we were doing in the last class. See, problem of language modeling is best solved by which systems? Problem of language modeling is best solved by which systems? Yes. Yes. So problem of language modeling is best solved by large language models. Okay, this is what they do. They do language modeling. Language modeling means predict the next word. Okay, and this is what large language models do by and large. Now, so what we were doing in this class, यार anybody knows कि इसमें कौन सी setting ज़्यादा हो रखी है भाई? This should be fine now. Can you still hear me? Okay. So, right. So we were talking about, this. So we were talking about the statistical way of doing things. Okay. If let's say I am to auto complete the next word, how will you do it statistically? How will you do it statistically? Just have a huge corpus, look at where did this n-gram last appeared, okay, and in how many, so let's say that same old thing, but I'll repeat it for the sake of completeness. Right. So we were talking about this example. After looking at the clock, the proctor asked the students to open there. Now, if you give me just 4 gram as the context, then the context is students to open their maybe books, right? Whatever, but exam takes a back seat. Exam will not be at the forefront. But if you give me this whole context, after looking at the clock, the proctor asked the students to open there. Now, exam is a much more likely thing here, right? Now, you have this many, but there is a trade-off when you are doing it statistically. What is the trade-off? The fact that in your whole corpus, you will have this whole sentence as it is. After looking at the clock, comma, the proctor asked the students to open there. That probability is much lesser compared to if you are just looking for students to open there, right? So, the probability of this whole sentence occurring is less than or equal to the students to open there. Why? Because it is simply smaller. laptop lids down, okay, right. So take this statistical input and start predicting the next word, and we saw there are a lot of problems with it. What happens if this n-gram has never occurred in your corpus? What will happen in that case? Since this has never occurred, I can't really predict the probability of next one, because the probability of this n-gram itself is 0. You can smoothen it, but we are not going on there because we are not going to do this way of language modeling anyway. So what we are interested in doing now is we want to do language modeling through neural networks. Okay. So we want to do So how will you do language modeling using RNNs? Now we are assuming that so for language modeling you need a bidirectional RNN or unidirectional? Yes, for language modeling you need bidirectional RNN or unidirectional. Think over it. Meanwhile, what should happen next? A1 will also be the output of this, okay. X2, we are trying to solve language modeling. So y hat 2 and so on, and this guy will be A2. Yes. How are we going to solve language modeling using RNNs? Huh? But if you are supposed to start something, so let us say you start with a 0 vector, null vector, okay. You want to generate a random sentence. So let us say your x1 is null right now, a0 is null, you say something. Whatever word comes out here, because it is language modeling, the next word prediction is conditioned on what was the first word. So this guy has to go as input. So your xt becomes y hat t minus 1, okay. So your xt basically is y hat t minus 1. But there are issues with this. What will be issues with this? So we are talking about training time right now, okay. What are issues with this? Simply this, that if this was garbage, this garbage is fed in here as well, garbage in, garbage out. So this thing will not make much sense, okay. Now one more thing that we have not done it yet, which is what will be the loss function. But loss functions we have seen before, so I just need to state them, and you just keep on doing this, okay. So what should I do to train this model? What is done is called teacher forcing. Okay. What happens in teacher forcing is, I have a corpus on which I want to train. So let us say you start with x1, okay. Now what will be your output to begin with? What will be y hat 1 to begin with? Will it be the actual next word in your training data set? You are just starting to train, you have given just the first example, the first word in your training data set. What will be the output of this neural network? the actual second word in your training data set? Yes or no? Yes. This is a question that can be answered. You want to train, you have a huge training data set, huge English corpus, you start with this. So, let us say you gave the first word as input, it runs through this neural network and it is supposed to give me output. What will be the output? Will it be the actual next word in your corpus? Yes or no? The answer to this is yes or no. What will it be? It won't be the next word, right? Or at least the probability of that will be very small because you have random things sitting here. It is not language modeling right now. It is not yet trained on the training corpus. So, most likely this won't be the actual next word. What you do is you take this for the computation of loss function. Okay, this is teacher forcing. So, you take the actual word predicted by the model as y1 hat to compute loss. So, this is to compute loss, but what you actually feed in here is not this right now, but actual x2. What are we doing here? क्या कर रहे हैं यहाँ पे अपन? See, I have a training data set that says, please give me a glass of water. I start training like this, that okay, please, okay, or I start with a null vector. I start with a null vector, and what will be the prediction here? Most likely something garbage, right, whatever it might be. I use that garbage word to compute my loss function, but the actual input that I feed in the next timestamp is not this garbage, but it is actually the word that was there in my training corpus. You keep on doing this. So, if you, let us say, do this for a few billion times, what will happen? Is this RNN trained now? Now you do not need to do teacher forcing. So, towards the beginning of your training, you will do teacher forcing, right, because you do not really want to waste time there, but towards the end of your training, you will not be doing teacher forcing. Is this part clear? If you are training something like RNN, LSTM, I mean RNNs and LSTMs are same thing, we will see it later, but so if you are training it from scratch, you will face this problem, because otherwise your training will take a lot of time. Any questions here? Okay. And so you keep on doing this. So towards the beginning of training, you do teacher forcing. Towards the end, you want that your system should be capable enough of generating the next word on its own. That some kind of, test phase is going on. Not exactly test, but you have removed teacher forcing towards the end. So do it in the beginning and not end. So how are we solving the problem of language modeling through RNNs? I simply give a null vector because initially I don't have any word. A0, run through these parameters, get the first word, whatever it is, use it for computation of loss, but don't feed it to the next one. Feed it whatever is the actual thing in your corpus. Keep on doing this. And towards the end, do whatever network says you to do. Okay. My question is, how will you compute loss in this case? losses are same as before. RNNs have not changed anything. देखो, RNNs do not change anything except this fact. Okay, so in RNNs your examples are slightly changed. So how examples change in sequence to sequence thing? How examples change in sequence to sequence? See, when you are talking about classification of images, there was an image and its label and it is standalone. It can go as first example, it can go as 13th example, it can go as 10,942nd example, no issues, right? In case of sequence, you have 50,000 reviews. Can first review go at the first place, 13th place and 20,000th place? Yes, it can, right? Your first example can go anywhere, second example can go anywhere. What is it that will not change? The sequence of that example. If that example says the movie was great, you can't change this sequence. So every example is a sequence. Huh. So examples are, so if we are talking about reviews, you have 50,000 reviews. How many examples do you have? 50,000. But each example consists of multiple words, right? So they are the timestamps in each example, and that has to follow a sequence. Okay, so the sequence to sequence thing comes from there. Each example you can of course always shuffle. First review is here. Why can't you train it in the last? Right? So if you have 50,000 reviews, you can randomly shuffle them and train whichever order. But every example is a paragraph, and there you can't change anything, right? Their sequence has to be maintained. Done? Chalo. So yes, what will be the loss function? I am doing language modeling, what will be the loss function? What will be the loss function? How many of you are at home with RNNs now? How many of you are okay with the concept of RNNs? Raise your hands. How many of you are not okay? Right. So let's talk a little bit about them first. So let's say this is, so I'm trying to train a language model. I'm given a huge corpus that has billions of words and it's actually a document, so the language flow is there. I want to make a RNN. What will be, and assume I have only one hidden layer. What will be the size of my input and output layer? Yes. What will be the size of my input and output layer? 300. Why 300? Because every word is converted into a 300 cross 1 embedding, so yes, 300. This we don't talk about. What about here? Output will also be a 300 because it will be one word from the corpus. What do you want as output? Your output could be any of the words. So this has to be a mod V thing. It can be first word in your vocabulary, it can be second word in your vocabulary, whatever it can be, right?
Input we are given the embedding of one word and we are expecting in output the embedding of the other word.
Yes, you are. But finally, so that is somewhere in between. At some point, you will have to convert those embeddings into one hot vectors. Like those embeddings, they were not embeddings to begin with. You had embedding matrix times the one hot vector of whatever, right? That gave you this one. You will reverse convert that here as well. Okay. So now, this is my RNN. Say whatever is here, I don't care how many number of neurons here. Now, I give first word as input. I expect the next word as output. So what is my neural network doing? This is a fully connected thing. I am not drawing the connections, right? But this is a fully connected thing. And similarly, right. I want to predict next word. First word was given here, and let's say it predicted the first output. It is one neural network. I don't have, this is this plain DNN right now that we know, right? What will I give input? So you have your language modeling, and your statement is, please give me a glass of water. You don't have RNN. This is my corpus. You don't have RNNs. Make a deep neural network to train this. To train for language modeling. Do it. I don't know RNNs. Jaldi batao. How will I do this? Give me a neural network that I can train on this. Give me a normal feed forward deep neural network. And you can assume that all these guys, they have word embeddings. So all are 300 cross 1 word embeddings. Can I make pairs? Assuming I am doing 1 gram. So my first pair will be my second pair will be, next pair will be, and so on. What will be the last pair? How many examples do I have? N minus 1, right? So I have this many examples. If I have a corpus of size 1 billion, I will have 1 billion examples minus 1. Okay. So I have that many examples. Can I train this neural network on these examples? Yes, I can. Please give comma me. Do, and are all these standalone examples? Can I train on this first and on this later and then on this and then on this? Can I do that? So can I make the ordering something like first this one, second this one, fourth this one, and third this one, and so on? Can I do this? Can I take any of the factorial n permutation and train? Yes or no? Kashish? Yes or no? Why can I do this? I have converted my corpus into training data set and I am nowhere making use of this fact that this is a sequence and it has to remain as it is, right? If I give up on this particular assumption, if I give up on this particular condition, I can train this neural network on these examples. But what is the problem? The problem here is these are not random sequences. These are not random choices. Basically, they are the sequences of this. They are part of this, right? So, what was the language modeling come again? Probability of Wi given all the way from W1 to Wi minus 1. What are these pairs doing? They are making each one as a standalone example. And tell me if this pair was okay or should I have done better? Can you give me better pairs? Can you give me better pairs? So for example, a better pair would be, please give, next example could be, and so on. Here I am giving how much context? Context of two previous words. Okay. If I increase this context, what will happen? My system will be better if I give context of just one word or if I give context of two words. Two words will be better. Now instead of two, if I make different kind of pairs with 3 grams here, what will that be? Please, comma, give, comma, me, and then output will be give. So if I want to make it, please give me, this is my context. If I give a context of 3 words, will that be better than 2 words? Yes. So if you are making these standalone examples, you are actually not making use of the fact that this was a sentence, this was a sequence. Okay, and I can so if I can I always make such pairs for whatever context I choose? Yes, I can. Okay, and for that, can I use this kind of a simple deep neural network? This is an example, this is my input, this is my output, so I can always use that. And what is problem with that? It still does not capture the fact that these guys are sequences. Why? Because the way you will give this as input to your neural network, you will lose the ordering. When you give input, please, comma, give, comma, me, this input will be same as give me please, me give please. Any 3 factorial permutation will be given as same input to this. Why? Nowhere we are making use of the fact that please comes before give and me comes after give. So you can't use simple neural networks. Where do RNNs come into picture? RNNs simply say, I am the same neural network that you were doing, this one, just that whatever you computed in the last time, give me. So now I have started a sequence kind of thing because previous computations are given to me as an input. So now the sequence in which you will give me examples, right? So here, first example, give it to me, whatever you did computations here, give it to me in the second timestamp. It is the same neural network, I am just unrolling it in terms of time. Okay? Questions here now.
So what will be the output y1 hat?
What will be the output y1 hat in this case? Since we are just beginning the training, it will be some random word. Right? It will be some random word. What will this? So, how will the structure of this neural network look like? I have mod v possibilities, and one more thing. I have in these lectures, I have completely overlooked something called unknown word, because your mod v will never be sufficient. You can always find a word that is not there in your vocabulary, right? But I am not taking care of those things. Those corner cases I am not taking care of. They just take time, and anyway don't occur in today's systems. Okay. So, for example, things like BERT, GPT, they won't have this problem with unknown words. It does not matter which word you are talking about, even if the system is seeing it for the first time, it knows a way to convert them into embeddings. So, forget if you don't get this, leave it. Will it be a distribution over mod v? As I wanted to do something else, but theek hai. Your input is a word. So basically one hot vector. You convert that into a 300 size embedding using your embedding matrix from word to vec or glove. You pass this through this neural network, your final output should be of mod v size, because it can be first word as output, it can be second word as output, and so on. Okay. Let us say output was this, I mean neural network says output is this and actual output was this. What will we do? Same good old thing that we have been doing in classification. What will we do? Which loss will you take? Which loss? Categorical cross entropy. What was that? You have mod v classes, so your output vector will be a one hot vector with 1 at the correct word, and rest everywhere it will be 0. What will you get from this softmax here? It will be a probability distribution over all the mod v words, and you would want your softmax to maximize the word for which there is a 1 in this iteration. I see only blank faces. जब हाँ that's what I am saying. We won't feed it to the next one. We will feed the correct one, but we will use this fact that you have done it wrong. I will use it for the computation of loss. I will use it for the computation of loss, but in the next timestamp I will feed the correct thing. ये वाली चीज कितने लोगों को नहीं समझ में आई है? एक बार raise your hands. What will I normally do in training? Whatever comes out, feed that. But if I do that, what will be wrong? If this was a garbage word, which it would be, because right now neural network is untrained, all these weights are random, so this word will be random. If I feed a random word, this will also be random. It will take me a long time as a network to understand and to understand the training data itself, right? Eventually I will be able to do so, but it will make my training slower. Instead, what you can do, it was random, it predicted something, use that for the computation of loss, but don't feed it here. Feed here whatever is the right thing. Keep on doing this, towards the end you will remove teacher forcing. Because no. Whatever is the loss, see, how will you compute loss for language modeling? Hint is we did it in some of the previous iterations. So what will be the loss? We did this in the class when we were writing that equation for language modeling. So you figure out what will be the metric. I wrote one long equation, if you remember, that was nothing but the loss function. When do you compute loss? See what will happen in this case. This is your first output. So your first example is done. I have one loss point. Then you come here, I have second loss point. So I will have these many, how many total predictions I will have? If it's a 1 billion corpus, then I have 1 billion predictions. How will they be connected? Output should be this, and output should be this, and output should be this, and so on. So what will be my loss? What is it that I would like to maximize or minimize? What would I like to maximize? What would I like to maximize? Maximize the probability of this guy. Then maximize the probability of this guy, and so on. The right word in your corpus. Maximize the probability of right word in your corpus to be output here. What will that be? So probability of W1, what will be the next term? What will be this guy? This is the probability of next word given first word was W1. So that will be P of W2 given W1. What will be the next one? P of W2 given W1, W2. Next one. So it will be eventually P of Wi given W1 to Wi minus 1, right? Okay. Everywhere I have a, so should I multiply this or what should I do? I have these examples. Are they standalone? No, they depend on the previous ones. So what will be the loss function? Multiply, right? So pi of all those, and this thing is called the perplexity. Okay, this is perplexity. How can I write perplexity? But I am digressing too much, right? So probability of W1 multiplied with probability of W2 given W1, and you keep on doing this. So basically you are trying to find the joint distribution of P of W1 to Wn of this whole corpus. Okay. I want questions now.
For the time step D minus 1.
Hmm.
So you say it is possible. The output may not be input for D.
So in teacher forcing, this will not be the input.
So how those two time steps are related now with A or
Shall I repeat this teacher forcing thing? See, initially will this be a random word? Yes, because my inputs and everything is random. But will my corpus have some actual word? Yes. So feed in that actual word and not what my network said the next word is. I should do this in the beginning, because in the beginning my neural network is random.
So, but actually we are feeding the x2 in the next time, in the next time.
So x2 means input for the next timestamp.
And what is actual x2?
So ideally this is what RNNs should do. Ideally, when you are doing language modeling, your xt should be y hat t minus 1, right? So whatever network says next word is, that should be the input here. But we are saying don't do that. You can of course do that, but you are already making a struggling network struggle more. So don't feed it the wrong word. It will take a huge amount of time for the network to figure out that it was wrong. That will happen by training. What we are saying, you predict something. Once you have predicted, we know that you have got it wrong. So if you have got it wrong, I must change my parameters. What is the purpose of getting this y hat? The purpose of getting this y hat is to get a loss function. That will help me train my parameters. Is that job done once you have output here? Right? Why do you want to feed a wrong thing here? Look at the corpus in your, look at the training corpus. Let's say the output word here is please. Let's say the output word here is please. And let's say in the corpus, instead of please, you have give. Teacher forcing says don't feed this please here, instead feed this give, because in your training corpus you have give and not please. This is hard. This is something you will write in your program. So your inputs are from the corpus and not from here. But when you are saying you want to make a language modeling RNN, you want to make a RNN that is capable of actually predicting the word which will go in as the input to the next timestamp. So teacher forcing, you do it in the beginning, but once you go towards the end, when you expect that your neural network is now smart enough, you don't do teacher forcing. Right. So once your parameters are not random anymore, you have learnt, let's say, billions of examples. Now you can simply go and relax this teacher forcing thing.
So how will we give the input if we are using 3 grams?
In this case,
Yes.
RNNs don't ask you to give input as 3 grams. RNNs will simply ask you to tell me this one. Input is please, output is give. Input is give, output is me. Right? This is what you give to RNNs.
So but when we are using
But this computation will be fed back through this particular thing.
so but when using teacher forcing, we are actually giving it y the same x2. Actually it is getting it.
Let's say x1 is please. Output should be give, but let's say network says glass. Network says glass, you use this class to compute the loss function and update the parameters. But this input that you are feeding, don't give glass, give.
What will be the second example and how will we feed it?
So next example will be now give, and your network should predict me. If it does not, let's say it predicts car. Use this prediction for computing of loss and update the parameters. But when you feed it to the next timestamp, feed me and not car. But since you are making a language modeling system, what is the job of it? The job of it is to predict the next word correctly. So towards the end, you should not be doing this teacher forcing. Towards the end, the network should be capable of predicting the right word. More questions here. So what is the function that the neural network has learned? See, this is where this particular thing comes into picture. If you don't have this, your computations are inherently sequential. Sorry, fragmented. They are standalone. This is the thing that makes it sequential. Yes, Astha, Adhiraj, Akshat, Amit, Arohi, Arukshita, Ashmit, Disha, Divyanshu, Ishan, Garv, Himanshu, Kanesh, Kashish, Keshav, Kushagra, Melissa, Muskan, Nilesh, Niharika, Paras, Payal, Rani, Ridhika, Riya, Saurabh, Srishti, Shreyansh, Siddhi, Saurabh, Swastik, Vaibhav, Vrinda, Yash, Yashpuri, Abhinav, Archita, Nitin. एक सेकेंड यार, 1 2 3 4 5 6 7 8, हाँ हाँ 10 से 11, सॉरी 10 से 1. सो अब प्रेजेंट कैसे करेंगे ये बताओ यार. हाँ हाँ
अभी पूछ रहे हैं लॉगिन करके आप कर लीजिए.
हाँ. So let me switch it off. Yeah, for